record this. So if you think back to all the factoring that we did in grades 9, 10, and 11, we're just going to review those today. And then we can look at factoring higher order polynomials such as power 3, power 4. So when you were in grade 9, you would have done common factoring. That was the first type of factoring that you did. So if I were starting off with my grade 9s and I were doing common factoring, I would just break down each term into its multiples. So I would say to them, well, a to the power 3 is a times a times a, and 2a squared is 2 times a times a, and what I'm looking for is what is common. Right? So I see they both have an a, they both have a second a, and that's it. So my common factor would be a squared. And then what goes in the bracket is what's left over. Okay, so this is not common in the first term, and this is not common in the second term, so that goes in the bracket. So generally, once you've gotten past grade 9, you don't have to do that. You can just kind of look at it, eyeball it, and see what's common and what's not. Sometimes students like to write what they are factoring out below each term so that it's easy to see what's left. Because remember that factoring is the inverse operation of expanding. Right? If I expand something, if I have a polynomial, if I expand, I am multiplying. And so if I factor, I am dividing. So basically when we're factoring a common factor, we're dividing. So when I look at this one and I look at what's common, well, I see they both could be divided by 5. The first term has 2 x's, the second has 3, so I can take out 2. I can't take any more than what I have. And then they both have y's. The first term has 3, the second term has 2, so I can take out 2 y's. So sometimes people like to write what they're factoring out below and then just divide to see what's left. So the 5x squared y is the numbers and variables that are common. And then in the first term, I would have a y left, right? The 5's were canceled. The x's, I've taken them out. I had 3, took out 2, got 1 left. In the second group, 15 divided by 5 is 3. I had 3 x's, I took out 2, so I have 1 left, and then the y's are gone. Okay, so that's just common factoring. Sometimes you might have a bracket that is common to both terms. So in this third question, I see that they both contain a similar bracket. So the question is 7x a plus b. Where is it? Plus 3y. So sometimes I don't want to just take out a number or a variable. Maybe I'm factoring out a common bracket. So I see that they both contain an a plus b. So that would be my common factor. That goes at the front. And then in the bracket, we're going to write in what's left. So here, a plus b has been factored out, and I would have 7x left. And then in the second term, a plus b's are factored out, and I would have 3y left. Okay, so sometimes it's a bracket or a binomial that's common instead of a number or a variable. So that was common factoring that you did in grade 9. Then we did some difference of squares. So I'm just going to add a little checklist in here. So generally when we factor, we ask 3 questions. Okay, so the first question we always ask, so let's just call this factoring strategies. So the first question we always ask, and it doesn't matter what type of factoring it is, we always ask if there is a common factor first. Right? Always. That's always the first question. Okay? Once you've asked that question, then you ask how many terms are there. because the number of terms will dictate what we're going to do next. So if there are 2 terms, then we're going to look and see if we have a difference of squares. Right, that's the only thing it could be. Other than the common factor, if it has 2 terms, we'll check for a difference of squares. If it has 3 terms, then we would ask, is it a simple trinomial or a harder one, a complex? Right, so that depends on the coefficient. We'll look at that in a second. And then if there are 4 or more terms, we're going to group. Right, so we probably do some grouping for that. So that's the next question I ask. How many terms are there? If there's 2, check for difference of squares. If there's 3, is it a simple or complex trinomial? If there's 4, I'm going to look and see if I can group. And then the last question I ask is, are we finished factoring? Right, sometimes you can do more than one type of factoring in a single question. So when the question says factor completely, it means that there may be more than one type of factoring. Okay, so if there are 2 terms, we might check to see if it's a difference of squares. So remember that a difference of squares is exactly what it says. It's a difference, so it needs to be subtraction of squares, so they both need to be squares, and it would have 2 terms. So how does that happen? Well, if we had something like a plus 3 times a minus 3, and I expanded, I can see that the middle terms add to 0, right? Negative 3a plus 3a, so I end up with 2 terms. So I end up with a difference of squares. I end up with a square minus a square. 2 terms, it is subtraction. They are both squares. Well, how does that happen? The factors must be the same but opposite. So when I expand the brackets, I can see that the 2 binomials are identical, except one's plus and one's minus. And what does that result in? Well, that results in the middle adding to 0. So really, I do have 3 terms, right? Even though it looks like 2 terms, I really do have 3 terms. It's just that the middle 2 terms are 0, right? So that's why it looks like there's only 2 terms. So I just have to recognize it. Once I recognize that it's a difference of squares, they're pretty easy to factor. So when I look at a squared minus b squared, immediately when I see 2 terms, I check the other questions. Is it subtraction? Yes, it is. Are they both squares? Yes, they are. So then it's pretty straightforward to factor. Both brackets have to be identical, but one is subtraction and one is addition. Doesn't matter which one. Okay, question 2. It has 2 terms. It is subtraction. 25 is a square because I can square root 25. X squared is obviously a square. 9 is a square because I can square root 9. And y squared is a square. So I know the brackets will be identical. So the square root of 25 is 5. And then we'd have x times x. The square root of 9 is 3. And then we'd have y times y. And then one's plus, one's minus. Okay. Question 3. Again, it is a difference of squares. It has 2 terms. It is subtraction. I can square root 25. You just have to be careful with this one because the 25 is at the beginning of the bracket and the x is at the end of the bracket. And then one's plus, one's minus. Just keep in mind, and I know students like to have the variable at the front, but this is not the same as x plus 5, x minus 5. It's not the same thing, because when I expand this, I get x squared minus 25. That's not the same as 25 minus x squared because the signs are backwards. right? So in the question, the 25 is positive and the x squared is negative. If I write it as x plus 5, x minus 5, I'm saying the opposite, that the 25 is negative and the x squared is positive. So just be careful. It does not matter if the 5's at the beginning of the bracket and the variable's at the end, okay? So even in my advanced functions, I have some students wanting to put the x at the front, even though they were told not to. Okay, question 4. Remember on our checklist, we always check for a common factor first. So in question 4, it's not a difference of squares right now because a to the power 3 is not a square, it's a cube. But if I were checking my checklist, I would see if there's a common factor, and I see if there's a common a. So I'm going to take that out. And then I have a difference of squares. So I have 2a minus 3, 2a plus 3. So that's what I'm talking about when I say, am I finished? Is there more than one factoring step? Sometimes it's a common and then something else. Okay, so just make sure that it's factored completely. And then the third one, a6 minus 64. Okay, it doesn't really look like a square, but a to the power 6 is a square because it's an even number. So if you square rooted a to the 6, you're just going to divide the 6 by 3, or by 2, sorry. So any even exponent is always a square. A to the third times a to the third. Remember that when you're multiplying, you add the exponents. So a to the third times a to the third is equal to a to the 6. And then the square root of 64 is 8. Okay, so any even exponent is always a square. Okay, so that's common factor, or difference of squares, which you did in probably grade 10. Okay, then we move on to trinomials. So we have 3 terms in a trinomial. A simple one means that the coefficient, the leading coefficient is just 1, right? There's a 1 there that we don't write, but we know it's there, okay? So these ones are called simple because all we have to do is determine 2 numbers that multiply to get the last term and add to get the middle term. Okay, so if I'm doing x squared plus 7x plus 12, I'm going to write down 12, and I'm going to think of all the combinations that are going to give me a 12. So 1 times 12, 2 times 6, or 3 times 4. And then I am also looking to see which combination adds to the middle term, which is 7. So I know it's 3 times 4. And so this would be x plus 3 times x plus 7. So remember, these are easy to check. I could do it in my head, but x times x is x squared. X times 7 is 7x, or that's a 4, sorry. Let me erase that. X plus 4. So x times x is x squared, x times 4x, x times 3x, and 12. So you can see that when we collect like terms, right, the middle term comes from adding the 4x and the 3x. The end term comes from multiplying 4 times 3, right? So that's why when we're doing simple trinomials, we just have to determine which 2 numbers multiply to get the end and add to get the middle. All you have to be careful of is signs. So for example, the next one multiplies to get 12, but adds to get negative 7. Well, if I have 2 numbers that multiply to get a positive, but add to get a negative, they would both have to be negative. So it would have to be negative 1 times negative 12, or negative 2 times negative 6, or negative 3 times negative 4. So again, it's 3 and 4, but this time they would both have to be negative because they would add to negative 7, but multiply to positive 12. if you're going to get anything wrong in the simple trinomials, it's signs. It's always signs. And then the last one has to multiply to be negative 12 and add to be positive 1. Well, if they multiply to be a negative, then one of them will have to be negative and one positive. So it could be negative 1 times positive 12 or positive 1 times negative 12. It could be negative 2 times positive 6 or 2 times negative 6, and then the same with the 3 and the 4. So when the last term is negative, it generally doubles your options, right? Because we could put the negative on the first number or the negative on the second number. It has to be positive 1. So negative 3 plus 4 is positive 1. And like I said, they're easy to check. You just multiply them. If you multiply and get what you started, then you're right. It's not that hard. Okay, then we have complex trinomials where the leading coefficient is not 1. So there's lots of different ways to do it. Whatever method you're comfortable doing is fine. We're just looking at the final results. Something like this, you could do it in your head if you wanted to. I would say, well, 2x squared has got to be 2x times x. It has to be. There's only one option to get 2. And then 3, the end, has to be 3 times 1. I just have to figure out what bracket to put the 3 and which bracket to put the 1, knowing that these two terms plus these two terms have to add to 5. So I would think, okay, if I put the 3 there, I get 6x, and if I put the 1 there, I get 1x, and I know I can get a 5 from a 6 and a 1, so that would have to be plus 6 minus 1. That would give me 5. So if you want to just do trial and error in your head, perfectly fine. Some teachers show you how to do crossover, where you're just trying different combinations. I'm going to show you decomposition, because decomposition is just a step-by-step process that always works. So in decomposition, you multiply the first number and the last number, and we get negative 6. So we're going to write down negative 6, and we're going to think of numbers that we could multiply together to get negative 6. So it could be negative 1, positive 6, positive 1, negative 6, negative 2, positive 3, positive 2, negative 3. We want to decompose the middle. That's why it's called decomposition. So decompose means break apart. So we want to, instead of writing 5x, we want to write it as two numbers that add to 5. So of this list of numbers I've got here, they have to multiply to get negative 6 and add to get positive 5. So that would be these two. So what I'm going to do is I'm going to decompose the middle, or replace the middle, with minus 1x plus 6x. So I have not changed the equation. I have replaced 5x with minus 1x plus 6x. That still adds to 5. So I have not changed the equation. It's kind of like someone having a $10 bill and you giving them two $5 bills, right? It still has a value of $10, except you just gave them 2 banknotes instead of 1. Okay? So once we've done that, we're going to group the first 2 and the last 2. And we're going to see what is common in that bracket. So in the first bracket, I see a common x. So I'll take that out. In the second bracket, we always start with that sign of the second bracket. So the second bracket begins with a plus. I see a common 3, so I'll take that out. And then if it can be done this way, this bracket and this bracket will be the same. If they are not the same, then you can't do it. Okay, so they must be the same. So now it's kind of like the common factoring we did earlier. We have a common bracket of 2x minus 1, and that leaves me with x plus 3 left over to go in the other bracket. Okay, which is the answer I got when I just did it in my head. Okay, So whatever method works for you, you can do trial and error, you can do crossover, you can do decomposition. Okay, so let's do this one. So always check for a common factor first. Nothing common. So I'm going to multiply 6 times 14. So what's that? 6 4s are 24, 6 1, so 84. So I have to list all the combinations that are going to give me an 84, and they have to add to 25. So I'm going to start with 1. I always start at the bottom. 2, 3 goes into 84. Let's see, 28 times. 4 goes into 24, 21 times. Well, right there I see a 25. I know that 4 and 21 add to 25, so I don't need to go any further. So we're going to replace 25x with plus 4x plus 21x. That still adds to 25. And then we're going to group first two and last two. In the first bracket, I see a common 2 and an x. We'll take that out. In the second bracket, I see a common 7. So we'll take that out. And now I can see that they both have a 3x plus 2. And then the 2x and the 7 go in the other bracket. Okay, I just want to show you that it doesn't matter. Sometimes I get asked, does it matter if I put the 4x first or the 21? Doesn't matter. Let's do it the other way. So let's say we put plus 21 plus 4. Right? That still adds to 25. I just did it in a different order. So let's group the first two and the last two and see what's common. So in the first bracket, I see a common 3 and x. In the second bracket, I see a common 2. And so when you're looking, the 2x plus 7 appears, right, to be common. And the 3x plus 2 is in the other bracket. So you end up with the same result. It's just that the binomial or the common factor that appears will be the other one, right? But either way, you're going to get the same result. Okay, what do we have here? Okay, the last type of factoring is grouping, right? So grouping, if we go back to our checklist here, we said we'll always check for common. 2 terms could be a difference of squares. 3 terms, either going to be a simple or a complex trinomial. 4 terms, you're going to have to group. So grouping is kind of like the middle step of decomposition, right? I have 4 terms, so I'm going to group the first 2 and the last 2, and I'm going to see what's common. So in the first bracket, I see a common y squared, so I'll take that out. Second bracket starts with a plus. I see a common 2, so I'll take that out. And then the y minus 1 is now common. And the y squared plus 2 goes in the other bracket. The only thing you have to check for is just make sure that the brackets, the factors that you have left, cannot be factored as well. Okay, because sometimes they can. All right, so let's group these two. So I'm going to group the first 2 and the last 2. In the first bracket, I see a common x squared. So I'll take that out. The second bracket starts with a negative, so make sure you take out the negative because you can't start a bracket with a negative. And I don't say anything common, so I'm just going to put a 1. Right, so negative x, take out a negative 1, gives me positive x. Positive 8, take out a negative 1, gives me negative 8. Right, so the binomial is the same. And then the x squared minus 1 goes in the second bracket. And then just be careful because X squared minus 1 is a difference of squares, so it can be factored again to x minus 1 plus 1, right? So that's when I'm saying that sometimes you need to ask, is it completely factored? Are there any more factoring that I can do in this question? Okay, and then these ones are just a little bit of couple of extra. So the first one here is just a difference of squares, right? There's two terms, they're both squares and it is subtraction, so it's pretty easy to do. Square root both terms and make sure that one's plus and one's minus. This one is a harder trinomial, right? There's nothing common. It has three terms and it has a coefficient. So I know I have to do decomposition. So 7 times 2 is 14. I list the numbers that multiply to get 14. And then I'm looking to replace the 15. So 1 plus 14 is 15. So we can replace that. So plus 1y plus 14y. And then we can group the first two and the last two. In the first bracket, I see a common y, so I'll take that out. The second bracket, I see a common 2, so I'll take that out. And then I see 7y plus 1 is common, so that's one factor, and then the y and the 2 go in the second bracket. Okay. Do I have any more here? Okay, so those are your different types of factoring that you should already know how to do. You should know how to common factor. You should already know how to do a difference of squares, and you should be able to factor complex and simple trinomials. And the grouping might be new, but you've probably done it in grade 11, I'm pretty certain. And then the very last question you always ask is, are we finished factoring? So before we get into any more types of factoring, you should make sure that you know how to do all the types that we just talked about today. I will say that when you leave high school, so high school is generally the math that you learn in high school are all the tools that you're going to need to learn and to be able to use to do more complex math. So factoring is one of those big skills in high school that you really, really need to know how to do, is how to factor.